All right, good afternoon and welcome to the PSU Friday Transportation Seminar. I'm very happy to introduce Shaun Quayle from Kittelson & Associates today, who's going to be talking about multimodal performance measurement on arterials here in the Portland region. So, Shaun, maybe you can tell us a little bit about yourself before you get started, but we're really happy to have you here.
Thank you,
It's all
Rob.
yours.
Appreciate that. Yeah, so a little bit of background about myself. I've been with Kittelson for 11 years. I worked in our Orlando office for 2 years, so different context to how transportation is done and just culturally what's valued. I think that was a good experience. And then I've been back here in Portland for about 7 years. And I do a lot of work in signal operations, optimization of signals, and so that obviously interfaces our intersections with every mode. And arterial performance measures, just performance measures in general, has become more and more of a focus topic. But I like to say that we were emphasizing performance measures before it was cool to emphasize performance measures. Not just because somebody was telling an agency, hey, you need to collect performance measures, but actually wanting to have information to make those decisions. Let's see, I am originally from the Portland area. I grew up in Tigard, so kind of suburban. So for my folks, it was a big deal to come downtown. So now working downtown, I've gotten a lot bigger handle of all of our different neighborhoods, streets, and I take the Maxon to work every day, so I get to see that transit side of things, as well as occasionally driving for meetings and other things. So, yeah, a little bit about myself. I've got, I think, like 37 slides. I don't know if we're going to get through them all. I'm going to buzz through stuff because it's in all likelihood you've seen some of it before. But make sure you're writing down questions, and then when we get to the Q&A at the end, let's buzz through that, okay? So let's start off with the big question. Why measure performance? Well, there's an old saying that whatever you measure gets done. So you set a goal, and you actually try to achieve it. But without setting a goal or keeping it out there as sort of nebulous, it's really easy to take the easy way out. And then related to performance measures, taking it one step further, we've always had performance measures in a lot of our transportation planning, engineering, operations, but a lot of it has been based on models or equations, so using the highway capacity manual and other things to approximate how a system would perform. Very rarely are we going back and actually measuring how well is the system performing with that new big box store or with the new cycle track put in. So what we want to focus on is how do we get to reality rather than something that's predictive. And as luck would have it, this is also a focus at the federal highway level. MAP 21 has quite a few provisions in place that say you shall collect performance measures. And it shall not just be freeways, it's going to be the national highway system. That includes major arterials. But the spirit of MAP 21, I think behind it is really accountability. Are we wisely investing the dollars that we have in projects, and are they working the way that we think they should? So a few examples of why not performance measures. Here's some of the things that we hear from agencies and clients and other folks that we work with. Number one, it costs a lot. Traditionally, performance measures have been collected manually, so it costs a lot to pay somebody to go out there, sit in the lawn chair with a little counter board and keep track of how many trips are going through an intersection. And that certainly adds up if you have to do it over a longer period of time. A lot of folks struggle with where to start. So again, this gets back to what is the objective of what you're trying to figure out from your transportation system. Do you care about reliability and you want to know day to day how much fluctuation is happening in demand? Or do you really just want to know on one day what's happening during that peak 15-minute period? There can be some challenges around technology as it relates to performance measures. So there isn't perfect technology for measuring every mode. At intersections, it's been, and this has been a big challenge within the industry, trying to understand how to reliably predict and detect bicycles at intersections, reliably detect pedestrians every single time at an intersection. And so a lot of times, because of those technology limitations, and I'll show this in the pilot project that we did here in Portland, we're relying on kind of approximations. So how many times does a pedestrian push the push button and actually receive service? How many times do they receive service versus how many pedestrians are at the intersection? So we can't tell you for sure that there are, using this automated method, 10 pedestrians that cross the street during that last hour. But what we can say is that, gosh, the ped movement was served 4 times. And so as planners and engineers, we use that as a trend to help understand what's happening within our transportation system. And then a big challenge, and something that Portland State has been really instrumental in leading the way with this, is how do we make the data useful? And to make the data useful, you have to be able to visualize the data. And so what you guys have here at Portland State with Portal really is helpful for providing access to the data. A lot of folks don't realize how much data is out there. For example, TriMet collects tons and tons of data about boardings and alightings, travel times for their buses, all using an AVL system. But until some of the recent efforts by Dr. Bertini and his crew to actually pull that data into Portal, it's been a challenge to get access to it. You have to know who to call at TriMet, what to ask for, and then blend that potentially together with other traffic data. And then, oftentimes, and this can be a valid reason, software can give you answers that might be close enough. And so if it is predictable and the software is close enough, there may not be a reason to not invest in the performance measures. But like I said, at the federal level and state and MPO level, there's going to be more requirements to measure performance over time. So this really started out as a precursor to the Highway Capacity Manual update. So we worked with Texas Transportation Institute and Purdue University to look at what's possible now with technology to be able to start measuring at the intersection performance. How long are vehicles waiting? What's the delay? What's the delay for pedestrians? What's the running time for our vehicles in the system? And back then, and this wasn't that long ago, about 10 or so years ago, it was buses. Buses were the only probes that we had in the system. Now with everybody's smartphone or with embedded vehicle devices with GPS, we're seeing a lot more probes in our network and being able to use those. Here locally in Portland, it started with a desire to plan for system management and operation. And so what's called TSMO, Transportation System Management and Operations, came together as a region. The DOT, the state, the cities, the county, TriMet, all these entities came together and said, how do we effectively plan for transportation within corridors? And one of the things that was a struggle to get our arms around was, well, what do we mean by arterial performance measures? There's so many different modes, there's so many different technologies out there, and they're changing really rapidly. And so the TSMO plan kind of laid the groundwork for what would be an upcoming project. The one that I'm going to focus on talking a little bit about is the arterial performance management concept of operations. This is an infographic that was put together by the folks over at Metro to try to help decision makers understand what we mean by system management and operations. It's simply just how do we effectively manage our system with the infrastructure that we have, or by adding little pieces, like say an app, to help folks understand what's going on in the network. And so you've got things like ramp metering that we're all familiar with, but there's weather stations, variable speed limits, real-time passenger display at transit stops, bike counters, a whole bunch of other things that take a little bit of planning because they have to work together as a system, but are well established within the marketplace. So in general, what's the data-driven vision for arterial performance measures? It's typically a cycle. You've got to define what you want to measure. So you need to know what your outcomes are first before you jump in and start collecting data. Then you've got either a program to go out there and regularly collect the data, or have something that's automated out there that's feeding the data back to us. You actually pull that data back, you validate it, which is really important to make sure your data is meaningful, and make sure that the data results, how they stack up against your outcomes and objectives. And lastly and importantly, you want to archive and share that data. So how do you get access to other stakeholders, other folks within the region that want that kind of information to help them make decisions with their upcoming projects? So again, you got to agree upon your outcomes and measures. You got to know your technology and be able to understand what's possible to collect. And I'll show you some examples of what we're doing here in Portland. You want to be able to use as much of the existing infrastructure as possible. This was an important outcome of that NCHRP research that was done. Is we've got a computer at every intersection in a traffic signal controller. Let's leverage it. Let's use it. Let's build standards around the controller to ask it to start collecting what's happening at the intersection so that we can start to have it do more than one function, which is turn the light red, yellow, green. And then we need to be able to fuse different data sources, and this is one of the big outcomes of the concept of operations, is the challenge with developing automated performance measures but actually having them work within different systems. And then it's important to be able to operate and maintain. So say you put out a radar detection system to be able to count cars as they go past the arterial link. You need some way to make sure that somebody's maintaining it. It's a new piece of infrastructure out there that's got to be maintained and operated, and so this is increasing workloads for public agencies, say City of Portland, for example. Are they allocating additional resources, whether that's funding or staff, to be able to maintain these extra devices that might be out there on the street? So those kind of thought processes all play into how do you want to develop and set up a performance measurement system. Or do you want to purchase the data from a third party and not have any of that maintenance issue, but you will still pay on an ongoing basis for somebody else to maintain that data set and provide it? So those institutional agreements and resources are really important. So I just threw this up there as a few examples. You can brainstorm 100 different potential outcomes on arterials because you have every different mode and you have all sorts of different objectives. So it could be safety driven, it could be bicycle throughput, it could be transit person throughput as different objectives. But at some level with your stakeholders, you have to get to the point where folks are agreeing that this is what we value in our projects, what we want our projects to accomplish, and then use that to set up your performance measurement system to make sure you're accomplishing that. And we're going to have planners, engineers, modelers, researchers, and the traveling public that may all be potential end users of the data. They're going to have different levels of technical expertise, and they're going to have different needs and desires for what the data looks like and how they'll use it. And that's not a bad thing. I think we can learn a lot from each other as planners, engineers, researchers, to be able to understand what the data is used for. But for example, researchers want the data at its base lowest level so that they can understand and do research on very specific questions, whereas planners may just be wanting to communicate to decision makers, hey, what's the change in travel time on this corridor as we put in a new signal system? And then the traveling public, they just want to know, how long will it take me to get from point A to point B? Pretty straightforward. So I'm going to jump in and talk a little bit about what we did here, specifically in Portland. So we were on a consulting team as a subconsultant to DKS, and we worked with ODOT, Metro, and all of the local cities and counties here in the Portland region to kind of brainstorm, what do we mean by arterial performance measures? What is this going to look like for us? And what we've put together is sort of a guidance document to help folks, because this is relatively new within the industry for what do we mean by some of these different technologies and how they get applied. So this is a simple kind of graphic showing what we're talking about. So you have a series of detection out there, say video cameras, radar, loops, a whole bunch of different devices to understand how travel is occurring and by who. And then you may have other devices that are out there, Bluetooth readers, probe data sets like INRIX, Wavetronics, or other radar traffic sensors. And the distinguishment is some of that detection is flowing through the controller. Some of it is going into a different server. But ultimately, what we want is that information to end up in a common place. In Portland, we've established Portal as that common place where we want to be able to feed the data into Portal and have folks be able to run their visualizations, reports, analyses. And that also takes care of the process of archiving and sharing the data. Portland State is going to take the effort of having the servers and the space to be able to store all this data that's coming off of the different detectors and devices that will be put out in Portland. So what does the guidance look like? This is a little bit hard to follow, but all it's meant to show is that there's a very intentional multimodal component to this arterial management performance program. So you've got things like bike counters, you've got Bluetooth readers that are picking up smartphones and other Bluetooth-enabled devices as they go by and re-identifying them later on down the road. You've got things like at the intersection, the ability to count cars and other things like that. And I'll show you very specifically some of the things. But the importance here is that the spacing and the location of these devices matter. So, for example, Bluetooth is a wireless protocol. And basically, you're using a radio and an antenna to passively listen for devices that are going by. Well, if you put Bluetooth readers too close to each other, say within 300 feet or closer, this is a passive net that's looking for vehicles that are going by. And if you move them too close together, you can end up with a situation where you have an eastbound trip looking like a westbound trip because the capture ranges actually overlap. So spacing becomes important. Counters at mid-block locations are important. So speed, if we want to measure speed at a mid-block location, if there's queuing that happens over those detectors, that's going to lead to errors and less confidence in the data. So again, that location is really important to get right. We developed some very general candidates for where we want to roll out arterial performance measures in more of a comprehensive perspective here in Portland. One, is the street of regional importance? Is it a major arterial and on the national highway system or not? Frequent transit service. Is it absolute major transit line, or does it have more than one transit line on it? Basic corridor readiness. This has to do with having the operations and maintenance support to take on additional devices that might be out there, and then having the brains, the signal controller, such that it's able to collect some of this data, and do we have communications to be able to pull this data back to a remote location so we don't have our planners, engineers, technicians running out there to pull down data from every intersection manually. What you have in front of you is a map of the pilot project that was done and led by the City of Portland. And we worked with the City of Portland to take basically 3 of their existing permanent count stations that was counting vehicles but was not counting speed. The single loop didn't work well. So we worked with them to add a second loop to each location. There's 3 locations along there. That allowed them to collect not just counts, but get speeds, get length-based classification, and be able to have that in addition to occupancy fed back into their central system. They already had, I believe it's 4 permanent Bluetooth stations out there. We have INRIX data coverage that we used in this evaluation. And then there was controllers out here. So there were new called Model 2070 controllers with Voyage software, which is the latest software running for our controllers here in the state. They have the most robust data collection mechanism to them. And having a variable message sign out there, as well as we also installed, and I'll show you in a second, some permanent bike counters on the Springwater Trail to be able to start getting trends for how many bicyclists are using the trail. I think the key findings and takeaway from our pilot project, to sort of give you the answer before I tell you the details, is we were able to successfully automate some of this data collection. But what was the biggest challenge is the interfaces are missing or incomplete. And so it was not easy to have the Bluetooth travel time fuse with the INRIX travel time and be able to compare the two. It was a manual process with the two. The counts, again, it was difficult to validate that the counts coming off of the intersection controllers were accurate because we had nothing to compare them to. We would have had to go out there and do manual counts to compare it. And then the other piece is just be aware of the strengths and weaknesses of the data sources. So some are easier to use, some have biases. And then, like I said, be careful of the locations to make sure we get things right. So I'll walk you through some of the different components. The simplest is an intersection count. So the way this is set up, you've got a controller up here. This is a Model 2070 controller running Voyage. And this actually shows an interface to one of two central systems used here in Portland. And what you've got here is a list of detectors. And this is for 4 p.m. to 5 p.m. on September 23rd at 185th and Cornell. And what it's showing you is the different detectors and the volume that was measured going over each of those detectors. Can anybody tell me what the northbound right turn movement is? What was the volume on the northbound right turn movement? We don't know, because we don't know what the detector number mapping is to. So again, it's that interface that nothing is exact, but it could be 205. You might be absolutely right. But that interface that's still required is something that we're still working through as an industry. How do we make sure that the data that we collect doesn't get lost in translation? We might have all these great automated data sources, but if the engineer can't figure out if that's a left turn or a through movement or a pedestrian or a bicycle, it can be a challenge. System detectors. So this is a picture down here of the modified loops out there, and we actually abandoned the loops that were there and recut two separate loops in the ground. These are inductive loops, and so they're measuring change in inductance as vehicles pass over the top. And you can see the display that's being used up here of Portal to be able to display the volumes and eventually speeds off of the data source. And then this is an example of a radar data collection device that's being used up in Clark County to do effectively the same thing. Measure using two beams instead of two loops the volume, speed, occupancy, and length-based classification off of a link of an arterial. Yeah.
How do the two measurement systems compare as far as costs to one another?
It can depend. Generally, radar is a little bit more expensive than loops traditionally. A lot of it has to do with the infrastructure that's required in the ground, because as soon as you have to lay in new conduit and trench, it gets exponentially more expensive, particularly if you don't have right-of-way. And so there are other wireless data collection devices out there that can work to overcome some of those barriers. It's a good question. So again, length-based classification is simply measuring the length and making some inference that longer vehicles are in fact trucks and classifying them that way. And that's actually the way that the Federal Highway Administration runs things. Length-based classification serves two different purposes. Obviously, we want to know the amount of trucks that are passing over our roadways to keep track of it, to understand trends, understand the changes if a new distribution center opens along the arterial. But also, the length-based classification allows us to be able to do some things related to speed and length and conditionally let the controller make some decisions about truck signal priority. So we could potentially use our detection system to do more than one thing. And truck signal priority, does everybody know what signal priority is? Basically holding the green for the bus to get through. In this case, it'd be holding the green to get the truck through. And again, there's lots of benefits that have been shown with truck signal priority to be able to help trucks get through. There isn't a worse place for a truck than right here at the front of the queue from an operations point of view, because they just have much longer acceleration profiles. And if that's the first one and they had to do a hard brake, that's a big impact to the pavement. And so that, again, is a resource that we have that we want to manage effectively. Next is bicycle count stations. So this shows a picture of the new bicycle count location put effectively between bollards to try to channelize bikes through and be able to get profiles of how long are people, or how many people are traveling through over time. And you see some results down here of during the PM peak, northbound and southbound on one count station, what happened. That happened to be, I think, in December on a rainy day, so it was a relatively low count. You look at this on a Sunday or a Saturday, and there's huge bike volumes. And all of this had been collected manually on the trails previously. What we wanted to do was be able to do this in an automated fashion. But one of the lessons learned with this is that bicyclists don't always ride in a single file line. In fact, they ride side by side quite often. And what we were seeing is we did some tests to make sure we weren't missing any bikes, and we weren't in the limited amount of sampling that we did. But we were missing bikes on the other side riding this way. And so we were actually potentially missing some folks. And so the next step is to figure out how to use this to capture directionality to augment the just simple counts that we were doing. Yeah?
I'm just curious, why is that sensor so far back from the bollards? Why would you put that device so that it really does get that? Because a cycle could go around that quite easily.
Yeah, that certainly could have been a change that could have been done for this. Again, this was a pilot, so it could be moved closer. But what we were seeing from the video is that folks were even riding around this bollard and coming through here too. So yeah, I mean, I guess you could put it here to try to capture that a little bit more. Again, it's that lesson learned to take away from the system. Know where your users that you want to count are going to be so that you place your detection accordingly. TriMet has a wealth of data, so a big part of this was communicating to stakeholders that this data is out there, it's available, and it's useful. So, you know, they wanted to see bus on-time performance. We were able to pull out of the controller the number of transit signal priority calls that were happening in each direction, and in some cases not happening at all. And then we wanted to be able to map ons and offs, because one of the things that we were struggling with as a team is, what's the pedestrian activity out here on this corridor, 82nd Avenue? There's no perfect technology to make sure that we're getting every pedestrian. And so let's think about this. And there was a great idea from a gentleman at TriMet. You know, a lot of locations out here like 82nd Avenue, most of the pedestrians are tied to a transit trip. So if we know the ons and offs within and around the bus stop, we can start to, at least at some level, approximate the level of transit activity or pedestrian activity happening in the corridor. And we can fuse that with the number of times that the PED service is happening at the intersection. Bluetooth data, so this is a picture of what the permanent Bluetooth readers look like. They've got a pair of antennas to enhance that range to make sure that we're not missing anybody that's going by, and you can see a blue dot to show where each of those permanent devices are. One of the questions that was brought up, particularly early in Bluetooth technology, is will we see a steady drop-off as more and more Bluetooth devices become encrypted, or you just can't get access to them? Will there be another standard that starts to take hold? And what we've seen over time is that Bluetooth is becoming more and more the de facto protocol for wireless communications, and that more and more vehicles are coming with Bluetooth, or more than one Bluetooth device within them. So what we're seeing is capture rates actually going up. So we're getting a richer data sample off of Bluetooth as we move forward relative to how it was a few years ago. And so that's what this is just showing, a comparison over a 6-month period, the change in Bluetooth devices that were happening at a couple different stations in the corridor. Again, with the aim that we want to get the best data possible, we may have to fuse this with other data sources, so we want to understand how accurate is each of the different data sources. And then the nice thing about Portal or any automated data source is these all look like simple text files until you start plotting them and turning them into meaningful information. And the ability to show, you know, what was the trip distance, what are the total trips, what's the average travel time, what's the standard deviation, what's the profile look like over time, in this case for travel time, between PAL and 8th and PAL and 42nd. So again, this is showing all the Bluetooth devices that are going through there. Who knows if this was somebody that was waiting at a bus stop and then eventually got on the bus and passed both of the readers. So there's little nuances like that in the data set that with an automated data source, you can't always tell the difference. So being aware of the accuracy of the data and the fidelity of the data is important. And then I would argue having this information on a continuous basis is so important. previously to evaluate something as simple as we're going to change the signal timing on this corridor. We would oftentimes change it, observe it, and drive or pay somebody to drive their car up and down the corridor to see if we met the objective of helping more cars get through with less stops. The problem with that is it's a very limited sample size, and depending on who's doing the before and after travel time runs in their car, they may have a bias objective. It may be, gosh, well, the consultant that I'm working for just did the retiming, and I really want the retiming to work, so go ahead and drive a little faster. If it turns yellow, just make sure you make it through. That's not necessarily what we want to be doing with our automated performance measures. That's why we want automated. And that's why we want to be able to have this over time, because even if you have a very limited sample size, if you can collect it every day, all hours of days, it starts to make up for some of those biases in the data set. So this is just a plot of, on 12th and Sherwood Road, before and after during the PM peak, the change with an adaptive signal system. And so you can see the percent change, and you can see the total time changed. And the nice thing is, on a 24-hour profile, you can plot this out and show before and after. So the after is in dark here. And westbound is on the top. Here's travel time, 0 to 400. And then eastbound is on the bottom. So what you're looking for is for change here to actually have occurred. And so we can present the data in a whole bunch of different perspectives. In this case, we actually mapped it out to the different time of day plans. But one of the things that, in this case, the county and ODOT wanted to understand is what's the change in reliability? And does everybody know what reliability is as a performance metric? Reliability is simply how reliable is the system over time. So oftentimes this is done using percentile travel times. So one common metric is buffer time. So how much extra time does a user, or say somebody that's driving a freight truck that has to be there on time, how much extra time do they have to put into their trip to make sure they make it there on time? And usually we're using 95th percentile travel times versus average travel times. So if it takes you on average 5 minutes to get to the airport, but sometimes it takes you 20 minutes, you're going to leave and allow for 20 minutes, even though most of the time you'll get there within 5 minutes. As we make changes to our network and help make things more reliable, what we'd like to see is that start to narrow in to where the average is much closer to the 95th. And that can happen with a variety of different treatments, including incident response. So ODOT has a program with their incident responders to address incidents on the roadways. Well, arterials, ODOT's not responding to, in most cases, arterial events. And so that's left to local law enforcement and tow truck drivers and other things like that. So showing this plot just to show you guys that the change in buffer time or reliability is relatively noise, except for one period, 3 to 6:30 p.m. So you could take a look at that data set and say, oh, it doesn't change that much. But if you know anything about the corridor, you know that that PM peak is the absolute worst time of day travel along that corridor. Lots and lots of trucks between 3 and 6:30 p.m. So a change in, or an improvement in this case, in reliability was something that was worthwhile to quantify. Again, couldn't have been done without that 24-hour, 7-day-a-week profile. And then origin destination data is becoming more and more important. I'll give you one example. Obviously, the planners are using OD measured information to validate their models. We've used Bluetooth origin destination information to help us understand, do we really want to provide a big green band, a large bandwidth is what it might be called, along an arterial to make sure everybody can travel from all the way from one end of the corridor all the way through? Or are people actually not traveling all the way through? So this is an example out in Washington County. So this is Cornell Road going along here. And you've got a station here, the beginning or origin, and you've got two different destinations. And we've got them color-coded here. And what's being plotted here is the last point that that Bluetooth device showed up. And so if we set up our timing to run everybody through, in fact, only about 40% of the trips are making it all the way from one end of the corridor to the other. Over 60% are turning here. And so the question is why? Well, take a look at the land use that's around, and it's the largest Costco in North America right there. But it also proves a point that you don't want to blindly go into a signal retiming or any sort of analysis saying, well, a really large band is good. That may be true, but it's not always true. And so this type of automated data is going to help, I think, improve industry, improve engineering, and improve planning. This just is showing the coverage that's available using INRIX. Does everybody know what INRIX is? Okay, good. You guys know what INRIX is. So this evaluation, again, this was done over a year ago, but we looked at what the Bluetooth travel times were on the arterial and compared that to the INRIX travel times that were being reported. Now, granted, this is not an apples to apples because the Bluetooth was based on very current 2012 data, and the INRIX data was based on 2010, I believe. But you can see that something is definitely off here because Bluetooth were showing 10 minutes and 40 seconds traveling northbound, and INRIX is showing 8 minutes and 10 seconds. That 2.5 minutes is substantial in its difference. And so I think it just begs the question of further research as to why these different data sources are producing different results. Which one's accurate, which one needs improvement. And then this is near and dear to my heart. This is the stuff that I get to spend the most time with. It's controllers, controller logs, and how well is our signal timing working. And so this just shows you an example. During one 60-minute time period, the number of times that each movement is served, that's the phase service. The number of times that pedestrians are served, that's not the times that they push the button, that's the times that the walk comes up. And then the average green time, the number of times that that movement maxes out or forces off. That basically means that there's still detection. It's still serving that movement at the end of the green. And basically it says, well, I can't give you any more. I've run out of the time that the engineers put in there for me to be able to serve you, which may or may not be a good thing. There may be good reasons to do that. Gap outs are situations where there was additional maximum green time that was programmed in there by the engineer, but the detection is showing that we don't need all of that green time. So again, it's helping us in an automated fashion understand which movements may not be getting enough green time to go out there and tweak the signal timing and make sure that it works to meet an objective, if that objective is to make sure folks don't have to wait through more than one cycle to be served, which is oftentimes called a split failure. And then getting to the ability to visualize this, this is using the 2070 Voyage software that's used throughout the state here to just showing the phases across here. And red is those situations where you have a lot more of the max outs or force offs happening where you're running out of green time for those movements. And what we want to do is see less yellow and red in before than we see after. And again, keeping this stuff simple is important for decision makers, bosses, and folks that you'll be working with once you graduate. Things like service delay log is something that's starting to become more and more prevalent. This was a kind of championed by Peter Kuntz here at the City of Portland, who wanted to understand for signal timing purposes, if I make my cycle length longer to try to move more cars, how much additional delay am I asking my pedestrians to wait around for? And is that having negative trade-offs with jaywalking or other things? So he wants to be able to, and we've been working with him and a whole bunch of other folks within the region to develop a way to measure delay by input. That could be a vehicle detector, it could be a pedestrian detector, it could be a bike loop. How long are each of these users having to wait before they get their green or go movement? And then you can start to relate that delay to level of service. So using the highway capacity manual at intersections, it's the average delay is average level of service. And like I said, pedestrians then can be mapped and plotted. Quality of coordination is important as well. And so this shows an example of using upstream detectors and simply keeping track of how many of those times that a vehicle goes over it is the signal green versus how many times when a vehicle goes over it is the signal red. And ideally, in a coordinated system, we're having a lot more vehicles show up when it's green than when it's red. That's going to result in less stops, better emissions, and so we want to be able to measure this. And here in the state, we have the ability to just lump that into how many arrived on green, how many arrived on red. And that can be plotted and show the net difference down here between arrivals on red and green before and after signal retiming. But what they're doing in Utah that's really interesting is they're using a stronger processor and a smarter, basically software within the controller to be able to plot this for every single actuation that's happening over that detector. And why that's important is we can see by cluster analysis, see if I can get my mouse cursor up here. You've got plotted along here. This is the start of red here, and it kind of loops back around. So this is all red time. That green line is when the green indication for that movement comes up. And then the yellow line is when the yellow starts. And so you can start to see when vehicles are arriving. And this is really important both from signal timing effectiveness for moving cars through, but also thinking through safety. We don't want a lot of folks showing up in the yellow or shortly after the red. What we want to have happen is the majority of folks like here showing up during green. And so that has to do with how we set up our signal timing to make sure that that works. The last specific piece that I'll point to, again related to safety, is this idea of a red clearance extension. So within Voyage, we have the ability to hold the red if somebody's detected in the intersection during the red. This allows us to potentially prevent near misses or crashes. And so it's just another feature to be aware of. And we're setting up logs right now to be able to measure that. So in summary, what are we collecting on our arterials here in Portland? So transit, and all of this data is coming from TriMet. You've got on-time performance, ons and offs, travel time, and the number of TSP requests. That last one, TSP request, actually does come from the controller. For pedestrians, we're collecting the number of times that the pedestrian phase is served and the number of transits on and offs and the pedestrian delay that's occurring. Basically the duration between when somebody pushes the button to the time when they get a walk. For bikes, we're collecting where we have the permanent detection, like this is shown here in this photo, number of bikes, and with that detection that's in an exclusive bike facility, the ability to measure the time from the actuation to the service can be inferred as the delay for the bicyclist. On the freight side of things, we're able to try to quantify the number of trucks using length-based classification, and then we're also able to capture using the controller log how often is truck signal priority being requested. And for autos, we can get the number of vehicles either using a system detector or the controller log, travel time with Bluetooth, NRIX, a whole bunch of other things. We can get speeds depending on the detection that's used, delay, quality of that coordination, and whether or not we're giving enough green time with max outs versus gap outs. So what are the next steps? So as an outcome of this pilot project and the stages that we're in right now as a consultant team, working with ODOT and the software vendors to help make these logs easier to use and improve those interfaces. So that includes the delay by input so that we can do pedestrian delay in an automated fashion in a very specific manner. TSP in a sense of being able to log the number of truck signal priorities. And red extension from the ability to be able to log the number of red extensions. And like I said, that improved interface is something that we're working through right now. It's not easy because you have 3 different entities that when something doesn't go right may not think it's their fault. And so you've got to get the local controller guys to work with the central software guys to work with the archive guys to be able to have a common interface and be able to understand the data so that it can be opened up to access for everybody. And then you guys fit in as researchers as well. You know, there's a need to validate that the data that's being pulled off of these automated sources are good and valid, and that it's usable for the different questions that are trying to be asked of our transportation system. And so we're continuing here in the region with future pilot projects. We've done some additional workshops. We're targeting upcoming projects and trying to work with agencies to say, hey, have you thought about adding a system detector here, or a radar unit here, or a Bluetooth reader here, to try to get momentum going around these data sources. Because the more that it's common, the more people will ask for it. So what's the takeaway? To do successful arterial performance, the data's got to be good. If the data's not any good, I think we're wasting our time. Secondly, it's got to be appropriate for what we're trying to answer as far as an outcome. And it needs to be easy to use. Time is a very finite resource, particularly within agencies, and so the easier that we present our story with the data, the more likely it's going to be used. Okay.
How long does it go for? How long does it last? Do you guys always work on it, or do you have a time, set time that you have to change after something?
Most of the time, we're collecting data on an ongoing basis where we can, where we have the space to do it. Then we may set up to only do logs for certain periods of time where we really want to know, say the AM and the PM peak, if there's limited space in the controller log to do it. But most of the time, we're trying to collect data on an ongoing basis.
Because sometimes people could change information really.
We didn't really hear the question.
Yeah, so the question was, is there variation in how long you want to collect the data? And basically the answer is we want to try to collect it for as long as possible, but we may not always be able to do it on an ongoing basis. Question?
Which trips are you trying to gather via Bluetooth? Because, like, as a pedestrian and a cyclist, I don't have my Bluetooth turned on, but my friends that are driving usually do.
Yeah, until we have an integrated Bluetooth on the bike.
It might be a lower rate of capture for bicyclists and pedestrians, potentially. Yeah, so there is a bias in that data set, and that's why it's important to understand the
Strengths and weaknesses of the data set. Is everybody able to hear, or do I need to repeat the question wrong?
Should be able to hear.
Okay.
On the Bluetooth again, in your opinion, are there any privacy issues arising when you scan, or is it just looking for some common signal when you hit the signal with the Bluetooth?
That's a very good question. So yes, there are privacy concerns, particularly from agencies. No, there is not a master linkage list that says that your cell phone has this media access control device address and it's labeled to you. They may be able to go back and figure that out, but what we've done is work with the agencies to truncate the MAC address. We don't capture the whole thing. And then in some cases, we've even encrypted it to make sure that we're protecting privacy. Gosh, I don't know who was first, so.
Just on the flow that you had from INRIX to Portal back out to Metro and ODOT, and that, where does the checks and balances go on for the validity of the data? Does it happen before it goes into Portal, or does Portal carry out that, whether it's valid data, and then decides what's going to go on to ODOT?
I can tell you my impression, and maybe Rob can even speak to what we've done here. The agencies most commonly are validating the data when it's a new technology, and then they're also doing a reasonableness check if it's turned in as part of an analysis report. There's usually more than one person looking at it to make sure it looks reasonable. But I'd say that rigorous evaluation happens the first time that the data set is developed and used. So you have a Bluetooth reader, you test it once in the region, make sure it works, and then you don't have enough money to do it every single time. We don't know. Does that answer your question?
Yep.
Okay.
It's probably a really simple answer, I'm sure. How do you deal with the problem of, like, let's say a bus goes by and it's got 30 users of Bluetooth devices on the bus? How do you guys deal with that? Obviously, it's just one vehicle going through an intersection.
Yeah, I mean, there has been some manufacturers that try to limit the amount of MAC addresses that they're taking in per second or half second to try to filter that out. My opinion is that shouldn't be done. I think that you just live with that bias that potentially can occur. And I've seen out in the field, because the way Bluetooth works is it's channel hopping, looking for different frequencies, is a bus will go by and at most you'll see 2 unique MAC addresses, usually. So that's just been my experiences out in the field. In the back?
So, with the first party or presentations, I couldn't get about enough information about your farm, but if your data will be very valuable for travelers, even travelers, individual researchers, planner. But my question is your data open to public, for the individual researchers or travelers?
More commonly what's done is that the data that's worthwhile to the motorists, like current travel times or projected travel times, is processed, refined, and in the state of Oregon, we work with ODOT that takes that data and plugs it into TripCheck. And so that's a website that's used. But then any of these sensors, if they're running through an agency, oftentimes they're being shared with third-party folks like INRIX that'll take the data and fuse it with theirs and try to make their data sets better. The irony of that is that they then turn around and sell that data back to the agency. So their own sensors are being packaged with additional sensors to improve the data set. Rob?
Question from the web. I'll just read it. It says, in one of the first graphics, you described engineers as operators of street systems and groups modeling with researchers. Yet we had a number of seminar topics on modeling that were given by engineers, and engineers developed the models. This leads to the impression that professionally there is not a lot of crossover between operations and modeling. Is this correct? If so, why not? Why isn't there more crossover?
I think we're using pretty general terms here, so I don't know that I can give you a straight answer. I will say that traditionally planning and operating have been done by 2 different agencies, or 2 different branches of agencies, and so they will talk when they need to cross over, but oftentimes people are busy, and so people take on the function which they're given, which planners will forecast out what this is going to be in 20 years and make sure that the model is calibrated to existing conditions. And then operators say, well, if we allow this development to go forward, what's going to be the projected growth that's going to happen that we'll have to account for in our roadway system? So there isn't an easy answer to that, but I think that the nice thing about performance measures is it crosses interests for engineers, operators, planners, researchers, that we all have a vested interest in what we're talking about today.
And I think there are, just my opinion, is there are a lot of efforts going on nationally trying to raise the level of operations consciousness, that we're operating the transportation system proactively and trying to raise up the level of the operations field, which traditionally has been more kind of in the maintenance area of an agency. So it's something that is evolving, and these kinds of projects are helping.
Yeah, absolutely. That's a great point. Other questions in the back?
How you can know what your data is validated or not?
Well, I think it has to do with the outcome that you're looking for and then the level of error and imprecision that you might be willing to accept from your data set. So say I put in these loops out there. What I want to know is how accurate are they? So do they have to be accurate within 5%, 1%? And the best way to figure that out is to video the intersection and make sure that you're capturing, manually looking at it. Okay, in the last hour, on video I saw 100 go by, and the loop says there's 102. So I've got a 2% error that's in there. So is that valid or not? Did that sort of answer your question? You've been waiting in the back.
I'm curious about reliability and if you've been collecting any way of a quantitative comparison between modes from automobile to bus to bike to walking in terms of reliability for the road user.
I think that's a great research topic. I'm not aware of anything that's been explicitly done. I'm sure that TriMet has really good data about the reliability of their system because they're using that to make investment decisions about the operators that they have out there and the number of buses. On the roadway side, there is a whole different focus on, mostly it's been freeways so far, on the reliability or unreliability of the system and developing a baseline since it's a relatively new performance metric. And then once you have that baseline, how do we figure out if it's good, within that one mode, but then also how do you take that information from the other modes? And that's something that we're seeing as more of a discussion at the national level too, and even here locally. Because really what we want to do is be able to use the capacity we have for person movement, not just to get cars through generally. Yeah?
You showed two examples of bike detection, and they were both loop detectors. And I was wondering if that's the best way to detect bikes, or if there are other options.
No, that's a good question. It certainly is not the only way to detect bikes. There's magnetometers, there's video, there's radar, everything that we're using to collect and detect vehicles we're using to also try to detect bicycles. It's just a little different way in that we try to do it. The big challenge is when you've got sort of shared space where the bicyclist is asked to be in the same lane as the auto, and distinguishing the two can be difficult because then you're trying to assume a size of a bicyclist versus an auto. And also you may want to distinguish a motorcycle from a bicyclist, and so they may not have that different profile of shape to be able to distinguish the two. So it's something the industry is still struggling with trying to figure out.
Do you guys periodically check the reliability of your measurements or measurement instruments, or is it just when you deploy them?
All I can do is say from our experiences, when we put them out, we make sure that they're working, and we do reasonableness checks as the data is coming in to make sure it doesn't look odd or weird. And I know that Portal does flag detectors that are broken or showing, results that are outside of a preset tolerance to at least have somebody go out there and check to see if the detector is working or not. It's a good question. Yeah.
You mentioned a whole bunch of different emerging technologies that are being used to counteract Bluetooth, different detectors, signal controllers. Is there any concern that there's going to be an oversaturation of data at some point? That they're just going to wind up with too much stuff, it'll be difficult to read through?
Yes. That's a good point. I mean,
never too much data.
It has to do with what your outcomes are, and I think there's so many different questions we're asking of our transportation systems nowadays, especially as Rob mentioned, we're trying to effectively operate them, that more data is going to be better, but people will have to pick and choose. I think the big challenge is how do you fuse it and have it be accessible to folks to turn it into useful information rather than just a whole bunch of mounted data that only a graduate researcher wants to go through.
Well, it's been a great discussion, and before we thank our speaker, just remind you that next week is PSU is closed on Friday, so have a happy Thanksgiving, everyone. And we'll see you the Friday after that for our last seminar, December 6th. Peak pedaling, has Portland bicycling reached the top of the logistic curve? This is a report on a recent Portland City Club study on bicycling in Portland. So we will see you then, and let's thank Shaun for his great presentation.